Hi, everybody. Yeah, so my name is Ethan Rosenthal. I manage a small team of AI engineers at Square, and I'm not going to talk about any of that fun stuff today. So, we do things with large language models and all sorts of hot stuff. And, you know, like with much of this job, I think the majority of my job is not doing that stuff, and it's instead dealing with the norm comfy things. And so today I'm going to talk about the absolute terrible time that I had trying to get my team's code base to build on an Apple M1 laptop. And so this is largely going to be a cathartic rant, but I hope that it's also, helpful, and maybe you all will learn something too along the way. So why am I talking about this today? I would be surprised if you could forget, but if you all remember our, intrepid NormConf leader, Vicky, sent out that tweet that was heard around the world back in July about creating this conference. And I was like nose deep into trying to get my team's code base to build on this M1. And I, kind of snarkily made a reply to that tweet. And here I am now, actually talking about that. So kind of fun to bring things full circle. So what is the M1? For those of you who don't know, back in 2020, Apple released a new line of laptops that use their M1 chip, which is kind of like the first time that Apple had created their own CPUs, like specifically for their laptops. And so they followed up like a year later with the M1 Pro and the M1 Max, and they had all these nice charts showing that you get more performance for lower power. And so a lot of people are excited about that. Who doesn't want their code to run faster? And who doesn't want to burn their thighs with their laptop when it's using too much power? And so this all seemed cool, but I was not very interested in any of this because, I know the first rule of programming, which is that you should never change anything. Like if it ain't broke, don't fix it. And my team's code base was working. And so I don't want to mess with like success. Unfortunately, time is like the one thing that changes that, none of us can stop that even if we wanted to. And so what happened at work was that in January 2022, it was announced that M1s were now available to new hires at the company, as well as people that were eligible to upgrade their laptop if, their current laptop was kind of old. And so they made that announcement, and one of the people on my team was kind of excited by these new laptops. And so they requested an upgrade. They got an M1, and they failed to get the code base to build. They spent about a week with this and no luck. And then a couple months later, another teammate tries to get a new M1, spends a week trying to build the code base, and they fail. And then in August, we knew that there would be two new members starting on the team, and they were going to be issued M1s. And I stupidly decided to start managing the team a couple weeks before. And so this meant that this was now my problem, and I was going to be the one that had to figure this out. And so like any good engineer, I completely underestimated how much work or time this could possibly take. But I tried to be reasonably smart about this. And so anytime you embark on something new at a company, I think it's a good idea to, check the wisdom of the masses. And, Square's the biggest company I've worked at. I used to work at some startups before this, and I never really appreciated how helpful it is to have a big company Slack. It's kind of like your own personal Reddit where you can get recommendations for like local accountants or holiday gift ideas and everything else. And so I decided to, delve into Slack to try to see if anybody else had already run into this problem before. And so, I'm reading through Slack search and other sorts of things, and I find these, esoteric Google Docs and Notion docs where other people had attempted to solve this problem. And if you search through these docs, you stumble upon these like incantations, right? These cryptic brew libraries that you have to install before you do anything, and these other cryptic environment variables that you have to set. And you don't understand what any of this means, but you're just gonna like copy and paste it and run it like everything else that you do with Stack Overflow. So I did that, and I thought, all right, like I'm good to go. Other people have run into this, I'll be good to go. And so the first step is, now that I've done my brew installing and set my environment variables, now I just need to install Python. Like my team's code base is built in Python. That's the first step. And immediately I failed because my team's code base was based on Python 3.7, which it turns out is not supported on Apple M1 laptops. And so now I find out that we can't use our version of Python. We're going to have to change the version of Python. thankfully, it's not like going from 2 to 3, but I'm guessing most of you out there probably don't like to change your version of Python too often. And so setting this Python version, this was kind of like the first node in this like tangled web of shit that I had to wade through. And so one recommendation I have is if you want to deal with different versions of Python, pyenv is a great little package that allows you to install different versions of Python on your laptop. And so then anytime you are, starting a new project, starting a new virtual environment, you can choose which version of Python you're going to use via that. And then, I had to decide which version of Python to use. And I think, my rule of thumb is to go with Goldilocks. So don't go with the latest and greatest 3.10 because, this is like on the bleeding edge. Don't go with the oldest 3.8 because it's, it was kind of like almost out of support by that point. And so just, go with something in the middle that's only a couple years old. So we chose 3.9. So this was like a 2 minor version upgrade that we went from 3.7 to 3.9. So now that I've changed my version of Python, this means that I'm going to have to change some of my Python dependencies because certain dependencies only work with, like certain versions of your dependencies only work with certain versions of Python. So what I mean by a Python dependency is like a library that you are pip installing, like NumPy or matplotlib or something like that. And so now I'm going to have to change the versions of these dependencies. But it's not just that I have to change them because they are now incompatible with my new version of Python. The other issue is that I have this brand new flashy sports car of a laptop, and there are no wheels. So Python wheels, for those of you who don't know, are like zip files where other people have kind of like pre-built your code so that it will run wherever you run your code. And so for a lot of these libraries, you need pre-built wheels in order to run this code on like your laptop or in the cloud or something like that. And it turned out that even if I had certain Python dependencies whose versions worked with my new version of Python, these versions of these dependencies did not work on Apple M1s. And so now I need to go and find what version actually introduced wheels that are compatible with the M1. Okay, so we've changed our version of Python. We've changed a whole bunch of Python dependencies, and then ideally you are not managing these dependencies yourself. I think if you're spending all day kind of hard coding all of your dependencies into a requirements.txt file, then you're not going to have a good time. But if you use a dependency manager, which is a tool where you can kind of declare, these are the high-level dependencies that I need for my package, then this manager will go out and find those dependencies, those dependencies, and this entire like nested graph. And it will make sure that it finds, the exact versions of all of the subdependencies such that everything will work and kind of, be reproducible every time you install your package. And beware, a little bit of self-promotion, but I have an entire blog post about this where my actual entire process around how I do data science is that every time I start a new project or analysis, I create an entire Python package and I manage all the dependencies with the dependency manager. And the nice thing here is that this means that 6 months later when I come back to the analysis because some stakeholder had a question in a Google Doc from an analysis that I ran 6 months ago, I can reinstall my package and rerun my analysis and have everything work. The other thing that I learned in this process is, it's kind of difficult sometimes to make sure that all of your different versions of your Python package actually all work together. And so what you end up finding is that, you run your dependency manager, try to get all your versions to work together, and the dependency manager spits out some, weird error saying, these two packages conflict with each other. There is no way that you can install all of these. So I kept running into this, and a very stupid skill that I now have is that I learned how to debug this pretty well. And my debugging strategy is that I create a minimum viable Python package. And so what that means is that instead of starting with my huge code base that has all these dependencies that takes, it takes a really long time to add a new dependency because you have to like traverse this giant graph, I create a tiny little new Python package. And I first install that offending dependency that seems to conflict with other ones. And then one by one, I start to add some new dependencies until the conflict appears. And then I know which exact dependencies are conflicting with each other. Hopefully, like, ChatGPT solves one day and you can just ask it, feed it your lock file and ask it what the issue is. But until then, you now have this very painful process that you get to go through too. Along the way, we were using pipenv as our dependency manager. I never really liked it. I always wanted to change to poetry, but I, don't like to change things at the same time because everything was working. But never let a good crisis go to waste. And so we ended up switching our dependency manager in the process. We also had to do this because for the life of me, I could not get SciPy to install with pipenv. I think there was a bug somewhere. And so this ended up being actually like a necessary requirement of this refactor. So now we've changed our version of Python, we've changed a whole bunch of dependencies, and we've changed the way that we actually install and manage those dependencies. And so, of course, we don't do all of this manually because we are engineers and we like to abstract stuff and build declarative systems. And so everybody's favorite declarative system, the makefile, and we have a couple 100-line makefile in our code base. This now needed to be updated to work with the new dependency manager. But thankfully, by this point, I actually got everything to build. So, I was able to build my code. I was able to run tests. I was able to, train some small models on my laptop. So I should be done, right? I fixed it for the new laptop. But unfortunately, code doesn't just run on our laptops. Code runs in the cloud. And the way that we run our code in the cloud is we build Docker images, at least on my team. So we use a Docker file to build a Docker image, and then we ship our code up to the cloud and run the code up there. And that Docker file is building the code that we are writing locally. And so there is kind of a natural coupling between the Docker file and our code base. And one of the things that the Docker file has to do is it has to install Python, it has to install Python dependencies and other sorts of things like that. And so this meant that I needed to update all of our Docker files so that they now worked with this new setup. But we don't just run regular code in the cloud. We run code on GPUs because we're training fun things like language models and everything else. And that code that runs on GPUs, we need to install CUDA, which is like the NVIDIA library. We need to install that in both the Docker container as well as the EC2 instances that the container is running on. And so now we have this other piece of our cobweb. If you go to NVIDIA's website, they have this diagram there where I think they're trying to argue that it's simple to do stuff on GPUs, and maybe it's a lot simpler than it used to be. But what you actually are not really, what's not entirely clear until you look closer at this is that there's this tight coupling that exists in GPUs between all sorts of layers of the stack. So you have to make sure that you have like the right versions of drivers and CUDA that are running on the actual instance that's running in the cloud. That is coupled to the version of these libraries that is running in the Docker container. And all of this gets coupled with the application that is actually doing the programming, which in our case is PyTorch code. And it turns out that all of this coupling is terrible, and it's like a lot of work, and it's a total pain. And I wanted to try to find the words, but I couldn't find the words to convey this to you. And so instead, I decided to burden some GPU hours and ask Stable Diffusion to paint me a Renaissance painting of a GPU burning in hell. And ironically, the hallmark of the GPU here is really the heatsink fans, which seem to be trying to dissipate the heat of hell. And so, yeah. So if you go to PyTorch's website, which is the deep learning library that we use, they have this wonderful little widget where you can pick, are you on Linux or Mac? Do you install your Python packages with pip? Which version of CUDA are you on? You pick all of these pieces, and then they give you this wonderful command that if you just run it, works most of the time in order to install these libraries. And all of this is great if you're on like the latest and greatest version of PyTorch, but for various reasons, my team was not. And so if you try to go back to earlier versions of PyTorch, this is the recommendation. So depending on which version of CUDA you're running, or if you need GPU support or not, and which platform you're on, you have all of these different pip commands with like pip indices and other sorts of things that you have to worry about. And so, I needed this to work with our dependency manager. And so I was having some trouble, so I decided to search on Google for how to, work with PyTorch and poetry, and stumbled upon, 36 comment GitHub issue that was prematurely closed because the problem was definitely not resolved. And so then a new issue was opened, And that issue is definitely still open because this is entirely unresolved right now. Um, and so I ended up doing something terrible. I had this beautiful dependency manager that allowed me to, declare my dependencies and it would figure everything out for me. And instead, I ended up kind of just having to hack and ruin it. So what I ended up deciding to do was that, in our code base, in the dependency manager, we would just install the version of PyTorch that does not have any GPU support because I don't have any GPUs locally. And then in our Docker file, we're going to first export a requirements.txt file from our dependency manager. So we will generate, kind of like running pip freeze, we're going to generate all of our requirements. And then I have this terrible sed command, which just substitutes the line of PyTorch with a hard-coded URL to a wheel of my exact version of PyTorch. And so it feels bad, but it works, and I haven't touched it since I made this change. And so maybe that's a sign that it's working. And if you're struggling with PyTorch and poetry, this hack, it actually does work. So sorry if you end up having to implement it too. So fine, we've figured out how to build our code locally. We've figured out how to make sure that that code also works in the cloud. We're good to go, right? Unfortunately, there's actually a third place that my team runs code, and that's in continuous integration. So anytime we want to merge our code into our main branch of our repo, we run various tests and things like that in our own build system, kind of like GitHub Actions. And so we need to do everything within continuous integration as well. And it was at this point that I realized that kind of like, I've been possibly blaming like a lot of other systems out there, right? Like, I've been complaining a bit about GPUs and poetry and all sorts of other things. And but part of this is my team's fault as well. And so one of our issues that I realized is that we had 3 entirely separate different processes for where our code runs. So when we're local on our laptop, we have one way of installing Python. You have to install a dependency manager, install those dependencies, and then run your tests or run your code. And so there's a very set process for doing that on your laptop. But then when you're in CI, there's an entirely separate process for installing Python, an entirely separate process for installing those dependencies. And there's a little bit of coupling between the two. We kind of use a make file for a little bit of this coupling, but not fully. And then within Docker, there's an entirely separate process for all of these. And so what this meant was that anytime I had to change one of these blocks, I had to change it in 3 different places. And so this is maybe a sign that we have not architected our setup in quite the right way. And so I realized actually after this that at previous companies that I'd worked at, we had been a bit smarter about this. And so one option is that you do all of your CI within the same Docker container that you're going to use when you run your code in the cloud. And this actually kind of makes sense because like the whole point of CI is to test your code in an environment that's fairly similar to the production environment, kind of like the same way that you create a test set with your machine learning model, because you want that test to be representative of what's going to actually happen when your model is running in the real world. And so one option is to use that exact same Docker container within CI so that you only have within that container, you have your method of installing Python and the dependencies and everything else. And then this way we actually, at least only have 2 ways of doing this. You can start to collapse this more, but I don't know, programming with Docker locally is not great. So what ended up actually happening? If you notice, it was August 2022 was when I needed to finish this by. If we go back and look at some of our timestamps, you can see that it was July 26th that I sent that tweet at Vicky. Next day, I submitted a PR. And my goal was to get that PR reviewed by August 3rd for the very important reason that I was going to be on vacation and I didn't want to have to worry about this after going on vacation. And sure enough, August 4th, it got merged. I went on vacation and somehow nothing broke. So that's the story of that. And you can find me elsewhere on the internet. And thank you all.